Okay, anybody can estimate. And I'm going to show you today a simple way to get started. I want to introduce you to a way that you can begin to estimate without having a lot of knowledge of how to estimate. It's basically trusting all of our knowledge that we put into the Best Bid Next Generation. It's going to create an estimate basically for you. It's going to give you the confidence to bid, turn in your numbers and know that you're covered without losing a lot of money or being extremely high and looking foolish. And we're going to give you the tools to get started with. So I'm amazed at how many people find estimating with electrical estimating software very hard. It doesn't really have to be. It can seem overwhelming when you try to accomplish everything all at once. You have to bite it off into small bite-sized pieces. The truth why so many people fail is I believe that they set their expectations far too high. I speak to people every day that buy the software and then try to produce an estimate on it that very afternoon. 90% will fail, maybe even more than 90%, and the other 10% that wouldn't fail already are skilled with estimating with electrical estimating software. In this video, I'm going to give you the simple steps that anybody can follow to produce an estimate. You don't really even have to have much electrical knowledge. And we realize that most of our customers are great electricians that just don't have estimating skills. Many people don't realize that once they navigate the learning curve, electrical estimating software is going to produce significant value for the rest of your whole electrical career. They don't feel like they have time to learn the software. They're just so busy. They're out in the field, or they're managing people, or they're stressed beyond belief. But if you dedicate the time to mastering Best Bid, it's going to ultimately save you incredible amounts of time and reduce your stress. It's going to be the best time spent you've ever had. The third reason, and probably the greatest of all of them, is people tend to try to be over picky or over specific in estimating. There's going to be time to learn how to navigate the software. Later on, you're going to have time to customize it, make it your own, change everything in it. Best Bid is the most flexible product on the market. You can convert any part of the software to do anything you want it to do. But let's forget about all that right off the bat. Let's just use it like it is right out of the box. Your main goal in the beginning, if you're not a seasoned estimator, is just produce an estimate that's going to cover cost, cover your labor, be competitive enough to win the job, and still make money. That's your goal. Eventually, you can create material lists that reflects your perfect format and focus on mastering the estimation process to go dive deeper. But let's just get you started. Don't get bogged down by the specifics. You don't need to enter a particular box with a certain bracket, a specific caddy part, a part number, all that stuff. As long as the software enters a box that covers all your costs for whatever box you're going to enter, you're going to be fine. You can change that later. Give it to your project manager. There's no need to figure out the exact lengths of black, red, blue, white, and green conductors. That's the biggest myth that I think people have. It doesn't really matter. As long as you have the total footage of conductor, you're going to be good. Focus on learning how to create a quick and accurate estimate. That's going to be your goal. What I'm going to show you is how to create your estimate without overthinking it. You're not really going to have to think it at all. If you're not an experienced estimator, this is going to get you closer with a reliable number than you would if you struggled to try to scale out everything and learn the software overnight. Just trust the software. In the following videos, you're going to see this process that I'm talking about work out in real life, and we're going to show you real life estimates and real life numbers. I don't feel the need to go step by step through this whole process because I've seen that people don't have a problem loading their drawings, and they don't seem to have a problem creating their groups. So I'm kind of going to skip that. What I want you to do is I simply want you to start counting. Count your lights, switches, receptacles, stub ups, and anything that needs to be counted. After you have these counts, all you have to do is enter these numbers into the software. Don't make any changes. Just trust the process. Anybody can count and measure, and anybody can enter a number. So now that you have your numbers, we counted lights, switches, receptacles, and stub ups. Let's just simply enter them. You're going to click the button. You're going to click Create a Light Anew. That's going to be the same every time. We'll add the multiple counts. Even if you can't figure out how to do that, you can enter your quantities, your tags. That's all you have to do is enter the quantities, tags, hit save. The software is going to produce you this material list. It's going to be close enough to win the job. Now all you have to do is go to switches. Change this to switches. Add multiple counts. It enters those in there. We're going to enter some 3-ways and 4-ways and single poles. If you don't know this step, you can open your viewer, go to switches, and there's how many that we have. 4, 7, and 6. All you have to do is hit save, assembly details, and the process is finished. I'm going to go to receptacles. I'm going to open up the receptacles. We're going to move this to receptacles. Add multiple counts. Enter your quantities. It's that simple. Save, assembly details. That's it. If you don't know how to get to this point, if you haven't learned that yet, just open up the master file, go to receptacles. You see that you have 6, 5, and 5. Just enter the quantities, mark them checked off. You're done. Save, assembly details. This is a great list. It's going to cover your boxes, your covers, your plaster rings, your conduit couplings, connectors, your devices, your plates, your screws. It's going to be your grounding stingers, your conductors, wire. A better list than you can create on your own. And it's going to be close enough. We're going by close enough today. So now we're going to go to stub ups. All you have to do is enter the amount of stub ups. Open your viewer if you don't remember. Go to stub ups. You had 16. Just enter 16 stub ups. Hit save, assembly details, and there's your products. It's that simple. Now you've already gone through almost all your counting and have it entered into the software. Simple as it can be. So what we're doing here so far is we're using a technique called averaging, which isn't perfect, but it is probably closer than you're going to get if you're not a seasoned estimator. So we have already, you haven't noticed it, and don't need to, but you've added 20 foot of conduit per light fixture. We've added 20 foot of conduit per switch. We've added 20 foot of conduit per receptacle without doing anything. You're going to see later on in the following videos just how close this technique comes to a real life job. It's not always perfect. You have to use a little common sense. If you're in a massive warehouse and the nearest receptacle is 50 foot away, obviously you can't use the 20 foot. But on jobs like you're going to see in the video, you can use this to get very close to a good average. You're still going to have to measure your home run stuff, such as your all your feeders, your air conditioning units, home runs like that, water heaters, panel feeders, your service. You're going to have to measure those and enter those. But we're going to get you more than halfway through just with what I've showed you so far. So I know some of you are going to say, yeah, but I want to use the MC cable and I want to do this. Forget that right now. Do your estimate with the default settings of EMT. If you want to install it in MC, that's perfectly fine. After you get the job, you can change it to MC cable and maybe pick up a little money. I know it's a faster install, material's a little high. If you just had to change it to MC, it's very simple, but you don't know how yet. You're going to just click your raceway type and change it to MC. That's all you have to do. But we're not talking about that today. We're talking about getting you started. So please bear with me. Just follow the steps, and by the end of this video, you're going to know how to estimate. Hey, today I want to sort of try my best to break down how to take off your branch circuits. Of course, this is not the only way, but if you're new to it and you don't quite understand it, there's got to be a starting point. You may develop a better way later down the line, but I'm going to get you started on a foolproof method that's going to help you to understand how to take off your branch circuits. So first you need to understand that we're going to generally try to use these three configurations. So 3/4 inch conduit with 7 number 12s. So black, red, blue, white, and green if this is a 122/08 volt surface. Y surface. So that's 3 hots. So we're going to try to catch 3 circuits. So we need 3 neutrals and a green. I'm going to call this A just to shorten the description. But this would come from the panel. And it's going to start by catching 3 different circuits. After we catch the first circuit and we drop off a black and a white, now we're only going to have 5 number 12s left. I'm going to call that B. When we leave this, we're going to now call that C. We're only going to have 3 wires left. So it's a 1/2 inch with 3. So what we would do, we would come from here to the panel. And this would be number A. This has enough wires to catch 3 circuits. This is going to represent circuit 1. This is going to represent circuit 2. This is going to represent circuit 3. So when you drop off for this circuit, now we're going to be into a B. Now when we leave this box, we're going to be down to a C. So So this is 3/4 with 7 number 12s. It's going to catch from here down is only going to be a C. So as we're catching all these and all these and all these, that's just going to be a C. Oh, well. So I hope that makes sense. But this is what we're doing is we're starting with 3 circuits. Once we drop one off, we only need 2 circuits. After we drop that off, we only need 1 circuit. So we'll have A, B, and C, or either 7 12s, 5 12s, and 3 12s. So I hope that kind of makes sense. Now when we get over to our drawing, what we want to do is we want to group 3 circuits together and call it a home run. So I've done A 23, 27, 25. So there's 23, 27, and 25. Each of these boxes will get the A circuit. So go through your drawing and try to group items that are very close together. So like here I put a box that's going to be 24, 28, and 21. And then I put together a box 32, 34, and 36. So down here I put together a box a 7, 9, 20. So here's 7, 9, and 20. Here I put together a box a 11, 13, and 15. So here's 11, 13, and 15. Now this leaves me with a box with just 2, 19 and 17. So here's 19 and 17. So everything is caught with a home run box that's already labeled and ready to go. So when you start your measuring, in this case I'm going to go to the panel, and then I'm going to go to the panel to this box. Then I'm going to go from the panel to this box. Go to the panel to this box. Go to the panel of this box. Now I've saved this one, but we have to catch it. So we'll go to the panel to this box. Now this box is only going to be a B because it only has 2 conductors in it. The rest of these are going to be A. That's our starting point. We've caught all of our home runs to our branch circuits now. All the ones that I've drawn besides this one is going to be this configuration, 3/4 with 7 number 12s. In earlier lessons, I showed you where you can just simply write your 7 for 7 number 12s on all your wires. That's going to be 7. So it's easier to remember. So that's the starting point. So we've got, that's called all of our home runs. Now the rest we'll be focusing on are the B and C configurations. So now we're going to focus on catching all the B's. So I changed this B to red already. So we're going to go back to our first box. And this is 23. So that'll be a C. And then 27, 25. So from this box that we created, we will have a B. Let me change the line color real quick. Okay, so we'll go from this box that's up here, we'll go to this circuit 27. Now we're going to go, let's choose another color. We'll go from the 27 to the 25. So this configuration right here is going to be all the yellow ones. This one will be all the red ones. And this will be all the black ones. Now you don't have to do all these color changes. I'm just trying to do this so you can see it in your mind of what you're doing. So now we've finished the circuit. We can finish it by completing that last run. So we would go down to here. We would catch this receptacle here. And catch these two, and now we would be complete with that one. So this one, we have our black. We're going to do our red with 5 to the second run. I don't know where these colors are. Okay, so this is 32, 34, 36. So there's our 32. So now we need to go down to 34 with the red. This one's 24, 28, 31. So there's 24, 28, 21. So from this box, we need to go to this one. And then this one's 27, 29. So from this box, we'll go to this one. And from this box, we'll go to this one. Now when we go to this second circuit, we've dropped off everything but the 3. So now we're going to go to the 3. I hope this is making sense. So after we've caught this 11, the rest of this circuit will be just 3 wires. Alright, so we've left off here. Here's our box, our 19 and our 17. Then we'll catch our circuit 17. This was the circuit 23 out of this box, so it's also going to be yellow from this box. This is 21 out of this box, so we did our 5, now we're doing our 3. So that's simply the way that you can do this and keep it all broke out, separate, and organized. There's other ways to do it, but this way will get you there if you follow this flow of things right here. So group 3 circuits together, catch it with 3/4 with 7 number 12s. After you drop off the first circuit, 1/2 inch with 5 number 12s. After you drop off the second circuit, 1/2 inch with 3 number 12s. So I hope this gives you an explanation of how to kind of do this. As always, have a blessed day. Thanks for watching. So now we're going to duplicate this on the Best Fit software. So I've created a power branch. I'm going to open the library and select a few choices that we're going to be using. So these will be our 3 choices. So this is going to be where we start our home runs. So our first home run is going to be from the panel to this box right here. The next one's going to be to this box right here. Then we'll go this box and this box. Then we'll catch this box. Now remember, we have a different setup over here, so we're going to catch this with 1/2 inch with 5 number 12s. Okay, so now we've caught all our home run boxes, and that's going to be the 3/4 with 7 number 12s. So now we're going to catch the 1/2 inch with 5 number 12s. So we started here, 23, 27, so we're going to go from this box to this circuit. So we're going to go from this box to this circuit. Then we'll go from 24s past 21, so we'll have to go from here to here. Then we'll go from this box to this second receptacle. So this box is going to continue to there, so let's go ahead and continue that. Then we're going to carry 5 down to here. And so that's it. So now we will just continue to finish out our branch circuits. So we can start from here, catch around the wall, it's already in that conduit, so we can start here. And you can do this a different way. It's just a way. It should help you understand to see how this works. So we'll finish this circuit here, a 19 and 7. So we'll catch all the way down to here. Start with, and then we'll catch around this wall. Okay, so we're up here. This was going to be a 3-wire by itself for this circuit. So 21 was going to be just a 3 to here, and then the rest of the way around. I'm trying to go slow enough that you can understand what's going on. So we had this box, we caught our 5 there, so we just need to go 3 over here to this one. We had our 5 to this one, so we'll go 3 to the next one. Whatever's on that circuit. Three from this 5. That should be close to it. So now that we've scaled this out and we have our final measurements, 1/2 inch with 3 number 12s, 1/2 inch with 5 number 12s, 3/4 with 7 number 12s, we have all the branch for these receptacles. Now I'm going to call everything a receptacle. There was a couple of air handling units that we caught with this, just because they were a circuit and they were easy to show. But we have counted the receptacles, and those points are 60. There's a total of 60 points. So let me show you something, share something with you. Okay, we had, in our measurements, we had 505 foot and 106. So that's 611 foot of conduit and wire. Remember that this is all horizontal. We haven't captured anything vertical which goes down to the receptacles. So we'll say the 60 points that we counted times 10 to go down the wall is 600. 611 plus 600 is 1200. So we're going to say that we have 1200 foot of conduit and wire. Now remember, we have 60 points. We could have just said 60 points times the average of 20 foot of raceway is 1200 foot. So we're within very close. Actually, this should say 1211. So we had 1211, and just by averaging 20 foot, we have 1200 foot. So that's just a pretty good argument that if you're not super skilled at estimating, that you could have just used the average of 20 foot and been plenty covered. Now you still have your home runs to scale to add to that. But even with that, there's a theory, let's just check it out, that you could take your longest home run, which would probably be this one, and your shortest home run, which is just straight above the panel actually. So that's 60 foot divided by 2. So we're dealing with 30 foot. So that, and we have 1, 2, 3, 4, 5, not counting this one because it's not the same. So 1, 2, 3, 4, 5. 5 times 30 is 150. And we actually had 140. So we're only 10 foot off. So we could have averaged that as well for the home run and certainly been in the ball game without all the scaling and everything else. So I hope that makes sense to you. So that would be 5 home runs times, there's 1, 2, 3, 4, 5, and the average of 60 is 30. 5 times 30 equals 150. So we could have either plugged in the 150 or with 140. That's the actual measurement. So for 10 foot, I think if you're not a skilled estimator, averaging it that way would be close enough to get you in the ball game. Now, while I'm on here, I'm going to show you one more little trick. If you're scaling And let's just take these two. We want to add 10 foot for the vertical if we were on the estimating side of the software. And we had our 60 outlets. We could change this distance apart to 10, and that would get us from the box down to the receptacle. So that's all we would have to do, and we would be complete with our estimating. So that would be our receptacle assembly. If we wanted to actually enter our scaled measurements for those, we just would simply go to the branch. We'll say this is 510 and this is 110. And then ½ inch was 7, which would be 140. Simple as that. Mark them complete. So there's no reason you shouldn't catch on to this. We may change this to receptacle branch or power branch.